Hey everybody, Mrs. Bodechon here. We are going to talk about our electricity AKS portfolio, and we are going to start off today with 10A. It says, I can use mathematical and computational thinking to support a claim regarding relationships among voltage, current, and resistance. So basically, we're going to be talking about Ohm's law. So you'll find this table on your AKS portfolio, and it asks you to fill out the symbol, the unit, and the definition for each one of these variables, the voltage, the current, and the resistance from Ohm's law. But it helps a lot to understand what Ohm's law is first. So I'm going to show you this, and we're going to go over each one. Okay, so I'm going to move this up here. First, we have the formula. The formula for Ohm's law is V equals IR. And you can see what these symbols represent below. V is for voltage, and that is measured in volts. I is for current, and it's measured in amps. And R is for resistance, and that's measured in ohms. Okay, so now let's go into the math. All we're doing is multiplying right here. There will be some times where you have to solve for a different variable, and I'll show you how to do that in a minute. But for right now, let's keep it simple and understand what these mean. So voltage is the potential difference. It's the difference in energy as a charge moves between 2 points in the path of a current. So I want you to picture like a wire, okay? And the voltage is really going to stem from your power source. So whether it's a generator or battery or whatever it is, your voltage stems from that. And I want you to kind of think of it as like the motivation that the electrons have to move, okay? So if they have like a lot of voltage, they have a lot of motivation to move, and they're moving really rapidly. And if they're not so motivated to move, the voltage is really low, your electrons aren't really going to be flowing so much, okay? Current, on the other hand, is the rate at which a charge passes a certain point. So in that wire, if you picture the electrons flowing, the actual flow, how many electrons are flowing, is your current, okay? So it's the flow of electrons and the quantity of that. That's going to be your current. So if your current's high, you have a lot of electrons flowing. And if your current's low, you just have a small amount of electrons flowing through your wire, okay? And resistance, the opposition to the flow of electric charge. So I want you to think of resistance kind of just what it sounds like. It's resisting the current. So inside your wire, it's kind of what's either slowing down the current and saying, whoa, hold up, slow down a minute, only a couple pass at a time, right? Or it's stopping it altogether, okay, and saying no more current flow, no more electricity beyond this point. So it's either going to slow it down or it's going to stop it altogether. So here's a little picture that kind of explains that. So here's our wire, and this blue part is our wire, right? And inside our wire, we know electrons flow. So we have our current. This is amps, this green guy, and that's our current, and he's flowing through the wire, right? And then we have voltage, which is really stemming from our power source, I guess like a battery or something. And that is the motivation behind our current flow, right? So that's kind of like the pusher of our current. If this guy is really super strong, we have a whole lot of voltage, our current's really going to be flowing. If this guy's really weak and we have a little bit of voltage, we're not going to have such a high current flow. And then over here we have resistance, which is our ohms, the red guy. And you can see he's kind of shrinking our wire, making it really hard for the current to flow. And well, resistance doesn't actually shrink the wire literally, but that's a really good way to think of it, okay? It kind of makes it so the current can slow down or stop altogether, okay? It only lets so much pass at a time, if you want to think of it that way. Now moving on to the math portion, I'm going to introduce you to our Ohm's Law triangle. And this triangle, you guys, is something we're going to be using all year long. The sooner you learn how to use this triangle, the easier your math is going to be, I promise. So when you're setting up your triangle, you always want to write what it equals on top. So in this case, our equation is V equals IR. So the V is going to go on top, and the IR and the R are going to go together on the bottom because they're being multiplied. Anything that's side by side is multiplied. Anything that is one on top of the other is divided. See how that looks like a division sign? V divided by I or V divided by R. And because they're next to each other, doesn't that kind of look like multiplication, right? So this is how you use it. If you want to solve for a variable, you cover it up. And I've circled them here because I can't cover it up, okay? So we're going to cover up V, and what's left? I times R. So that's our equation. All we would do is multiply. If we're solving for I, all we have to do is cover up the I. And notice you have V over R. V over R is V divided by R. Okay, so just division. And then if we're searching for resistance, we're just going to cover up that R. And we have V over I, so V divided by I. And then we can do our simple math, and we're done with our Ohm's Law math, okay? So on your sheet, you have all of these lovely math problems to do. Go ahead and try them out, and we're going to work them together. So here is our first one. It says, what current flows through a hairdryer plugged into a 110 volt circuit if it has a resistance of 25 ohms? So the very first thing we need to do is we need to write down our knowns, right? What are we given? In this case, we are given that we have 110 volts. So I wrote it here, volts equals 110, that's our voltage. And it also tells us that we have 25 ohms. 25 ohms is our resistance. And you guys will get to just memorize that ohms means resistance. It just is going to take a little bit of time, okay? We need to write down our equation. So in this case, it says what current flows, which means we need to cover up that I, and we are left with V divided by R. So I went ahead and I wrote that here for you. And we're going to substitute in what we have. I equals V, which is 110, divided by our R, which is 25. If you put it in your calculator, you get 4.4. And I, which is current, is measured in amps. So you can write a capital A, or you can just spell out amps. Either way is fine. It means the same thing. Moving on to our second question here. It says, an electric heater works by passing a current of 100 amps through a coiled metal wire, making it red hot. If the resistance of the wire is 1.1 ohms, what voltage must be applied to it? Well, let's look at our knowns. We have a current of 100 amps, so our current I is 100 amps. And then it says it has a resistance of 1.1 ohms. So our resistance R is 1.1 ohms. And then we need to write our equation. What's the voltage? Again, we cover up that V, and we can see that I and R are next to one another, which means we're going to be multiplying. V equals IR. Substitute in what you know. So V equals I, 100, times our R, 1.1. If you do that in a calculator, you get 110 volts, because voltage is measured in volts, or AV. Last math problem on your sheet. It says a subwoofer needs a household voltage of 110 volts to push a current of 5.5 amps through its coil circuit, right? What is the resistance of the subwoofer? So we know we have 110 volts, that is V for voltage, and it's pushing the 5.5 amps, that is going to be I, right? 5.5 amps. What is the resistance? Go ahead and cover up that R. You can see that we have V divided by I, which is right here for you. And let's substitute in what we know. So R equals V, which is 110, divided by I, which is 5.5. Put it in your calculator and you get 20 ohms. Notice this is a Greek symbol. You can write this, kind of looks like a funky upside down horseshoe, right? Or you can just write ohms. Either one would be correct, but just know that it stands for ohms, you guys, okay? All right, and then you're given these sentences, and you are asked to complete them by circling which one is really correct, right? So let's read them over together. It says a current through a wire decreases when resistance increases, right? So the current, remember, is the flow through the wire. So the current will decrease, means slow down, right? Or not be as many electrons flowing through that wire when we resist that current flow. So think of that guy like squeezing on the wire, even though it's not really happening, right? That just lets us think of it really easily. And the next sentence, a current through the wire, remember we're talking about the amount of electrons flowing, right, through our wire, increases when the voltage increases. So remember, voltage is like the guy pushing the current, and that's kind of like the motivation of those electrons. So if those electrons are highly motivated to move, you're going to have a huge current flow, right? So the more voltage, the more current that you have. And let me show you the simulation. Okay, and I just wanted to very quickly show you this Ohm's Law simulation, you guys. This is our equation, so V equals IR. I know they're kind of in weird shapes right now, but you're going to see why in a second. You have a circuit below. This is just a simple circuit. So we have our batteries here, which is where our voltage will stem from, right? This black line is our wire, and we have a resistor. Okay, you can see these dots are how much resistance is there, kind of slowing down our current flow. And it's telling you how much our current flow is here. And we have these little switches that we can move up and down to increase or decrease our resistance. Notice voltage is measured in volts and resistance is measured in ohms. So right now what I'm going to do is I'm going to increase my voltage. What I'm really doing by that is I'm adding more batteries. So you can see I'm adding another battery, I'm adding another battery, and you can see what's really happening when I do that. When I'm doing that, obviously my voltage is increasing, right? But what else increased? Did you guys see anything happen to current when it was going? I'm going to start it over. So watch the current. It definitely increased as well, right? So when voltage increases, current flow also increases because remember, it's like the motivation behind it kind of pushing it along, right? Okay, so let me go back down to the middle right here. Okay, now what do you think would happen if I increased resistance? Think about that for a second. Okay, as we increase resistance, you can see that yes, our R got huge because we increased resistance, right? But our I for current flow also shrunk significantly. And if you saw the resistor in the circuit, we have a lot more dots happening now because we've increased that resistance. So all of a sudden our flow of current is being pushed back a little bit more. Not a lot of current is allowed to flow past that resistor. So we definitely increase that flow. Now the same thing would happen in reverse if we reduce the resistance, right? So if I reduce the resistance, you can see that my current flow is really getting larger at this point, and look how many dots are left. We've almost removed all the resistance in our circuit, so our current is just flowing very rapidly at this point. And then the last one would be, what if I decrease my voltage? If I do that, you can see it's also decreasing my current flow. I only have one battery now, so there's not a whole lot of motivation behind these electrons to get them moving and flowing, right? So my current flow is going to be pretty low. That just means there's less electrons flowing at a time, right? So that pretty much sums up Ohm's law, you guys. If you have any questions, let me know.